Welcome to qiphyedu. Today we'll be looking at Computer Science A2 level, paper 31, May-June 2023. Alright, let's start. Okay, so for the first question, it says numbers are stored in two different computer systems by using floating point representation. System 1 uses 10 bits for the mantissa, 6 bits for the exponent, 2's complement form for both the mantissa and the exponent. System 2 uses 8 bits for the mantissa and 8 bits for the exponent, and it's the same for system 2, which is also 2's complement. And we need to calculate the normalized floating point representation of 113.75 and show how it would be represented in each of these two systems. Okay, so here we can then separate it like this, just separate into 113 plus 0.75. Okay, so you can see here, because this is 0.75, then we can immediately know that this is 0.5 plus 0.25. And then both of these will belong in the rightmost 2 bits, right? So these two will be reserved for 0.75. So we can just directly start on the left, on the third bit here, from the right. This will be 2 power of 0, all the way until 2 power of 7. But then here you need to remember that this is 2's complement form, which means that it could be either it could be a positive number or negative number. So the leftmost bit here, or the most significant bit, is used to represent a positive number or negative number. So 1 is negative number, 0 is positive number, right? So we cannot use this for 2 power of 7. Okay, so since this is a positive number, we can just put 0, right? And then the rightmost 2 bits, starting from the left, that will be 1 divided by 2 power of 1, and then the rightmost one will be 1 divided by 2 power of 2. So 1 divided by 2 power of 1 will basically be 0.5, and 1 divided by 2 power of 2 is basically 1 over 4, which is also 0.25. So when you add 2 together, you get 0.75. So we can just put 1 in both of these slots. Okay, so now let's calculate 113. So 2 power of 6 is 64, so we can just put 1 in here. And then 2 power of 5 is 32, just put 1 in here. So 64 plus 32, we get 96. So 113 minus 96, we still get 17. So 2 power of 4 is 16, so we just put 1. So now we only left 1, so we can just ignore 2 power of 3, 2 power of 2, and also 2 power of 1. So just put 0, 0, 0, and then we put 1 here. Okay, so this is the representation of 113.75 in normalized floating point. But now we need to calculate the exponent. Okay, so you need to remember that the exponent is calculated by starting from this particular dot here. Okay, this dot, which is between the first bit and the second bit. Then we need to go all the way to the point where it is between 2 power of 0 and 1 divided by 2 power of 1, because that's where it's where 113 and 0.75 is divided. So we can just do that by using arrows to jump from one bit to another. In this case, it's from left to right. So this one is 1, 2, 3, 4, 5, 6, 7. So here is a dot. So 7 in exponent form would be in 2-bit form would be 1, 1, 1. So we can just take 0, 0, 0 and put in the leftmost bit, and then 1, 1, 1, which equals to 7. Okay, so this is the answer. And then for system 2, it could be calculated like this. Because this is 8 bits for mantissa and 8 bits for exponent, we can just directly take the numbers here and move it down. But you cannot take the numbers at the back because there's no space for it. So just put 0, 1, 1, 1, and then 0, 0, 0, 1. Okay? And then this one, it's also the same, it's also 7, so just put 0, 0, 0, 0, 0 until you have 3 bits left, and put 1, 1, 1. Okay, and then you realize that there's one error, or not error, but there's an issue here. Because of the fact that there is 2 bits missing from system 2, you cannot represent 0.75, which leads us to our next question, which is, explain the problem that occurred in part A when representing the number in system 2. So, what we can say here is that the mantissa in system 2 does not have enough space bits to store the whole binary number So this is 1 mark, and then the second mark will be therefore the accuracy of the number is decreased. Okay, so this is 2 marks. There you go. Okay, now let's move on to question 2a. Draw one line from each machine learning category to its most appropriate description. Okay, so supervised learning is basically the learning itself, based on its term, is basically when it's supervised. So you're giving examples to the machine to learn what will happen when you input a number, you output a specific number. So this would be enables learning by mapping an input to an output based on example input-output pairs. So we just draw a line to that. And then reinforcement learning is basically when you learn through trial and error. So that will be fourth description, enables learning in an interactive environment by trial and error. Okay. Then deep learning is basically related to the human brain, because deep learning, you're learning deeply, you're learning using your brain's capabilities to make decisions. So this one goes to the top. And then unsupervised learning is basically, well, as the name suggests, learning that's not supervised. Basically, you are learning by discovering things that are previously undetected, basically patterns. So this will be the last one. Alright. And then B, describe the purpose of both the A-star algorithm and the Dijkstra's algorithm, which basically is to identify the shortest path between two nodes based on time required. Okay, so for this question, it says it's a 2-mark question, but actually this entire thing is 1 mark. This is 2 mark. Then this is already the 2nd mark. Then this is the 3rd mark. Okay, so it's better to write more so you get more marks, especially for longer, answers like this one. Okay, question 3a. A hashing algorithm is used to calculate storage locations for records in a random access file. It calculates hash values by using the function modulus 3. The function modulus gives the remainder after integer division. For example, 1030 modulus 3 equals to 1. Therefore, the record key 1030 gives a hash value of 1. Complete the table to show the remaining hash values. Okay, so let's look at 1050. You then divide it by 3. So if you divide it by 3, you realize that you'll get 350. So the remainder is 0, so your hash value would be 0. Okay, now let's look at 1025, and then we divide it by 3. So if you take 1025 and divide by 3, you'll get a remainder of 2. So your hash value would be 2. Right? So B says describe what happens in relation to the storage or retrieval of a record in the file when the calculated hash value is a duplicate of a previously calculated hash value for a different record key. So what will happen is a collision will occur. When the record key doesn't match the stored record key. Okay, this is 1 mark, and then 2nd mark would be if the record is to be stored, the file should be searched linearly to find the next available space. If the record is to be found the overlay area, the overflow area, sorry, the overflow area should be search linearly until the matching record key is found. Okay, so let's move on to question 4. Two descriptions of a user-defined data types are given. Give appropriate type declaration statements for each, including appropriate names. A data type is to hold data type to hold a set of prime numbers below 20. These prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. Okay, so this one we just put type prime equals, this is a enumerated data type by the way, so equals, then we just put all the numbers in, so 2, 3, 5, 7, 11, 13, 17, 19, right? So this is the answer. And then B, it says a data type to point to a day in the week. Okay, point to a day in the week. So this one is, let's say for example, Monday. So type T day point equals to this up symbol, then put day of week, just redirecting it to another type, right? So it will look something like this. And then 5a, state with a reason where it would be appropriate to use circuit switching. Okay, so circuit switching is basically when you it's basically this particular type of switching. Okay, like as the name suggests, it's basically switching your circuit. So this would be used when you want full bandwidth and then when you're calling. So you can say use for calling as it requires the entire bandwidth. And then a typical application is video streaming. Okay, 2 marks. And B, give 2 benefits and 2 drawbacks of circuit switching. Benefit 1 is basically whole bandwidth available. There will be no data loss. Okay, no data loss. But the drawback here would be if the circuit breaks down, there will be no alternative paths available or alternative routes. And then the second drawback would be time required to establish a physical link. Between 2 stations. Can be long because this is circuit switching. It needs to go through a very long line, right? Unlike packet switching, which directly goes onto the internet. Right. So now question 6. Several syntax diagrams are shown. Okay, operator, digit, symbol, letter, password, and state whether each of the following passwords is valid or invalid and give a reason for your choice. Okay, so this one is DPAD $99 . So let's look at the password because this is for password. So letter here is you can repeat the letters as many times as you want, so it's unlimited. Same goes for digit and symbols. So the first letter is D. Let's look at letter and see if there's D. Okay, there is. So this one is correct. And then let's look if there's P. There is. And let's look if there's A. There is. And there's also D. So that's correct. And then let's look at digit. See if there's 9. There is. So both of this correct. And then dollar sign, is it available? Yes, there is. So this one is valid. And the reason for that is there are 4 letters followed by 2 digits and 1 symbol. Okay, now let's look at the second one. It's DAD hashtag 95. Okay, so just now we already saw D and A existing in the letter portion, so this 3 will be valid. And then let's look at the hashtag symbol and see if it's available. The answer is yes. Okay, so then just put that. But you realize something. You cannot go to the hashtag symbol immediately. You need to go to digit first. So I already made a mistake here. You cannot go directly to hashtag. So this is wrong. So this is invalid. And the reason for that being, there are no numbers between there are no numbers between sorry, there are no digits. We should use digits because that's a term here. There are no digits between the letters and the symbol. Okay, now let's look at the last one. It's ADY123. So AD exists. Let's look at Y. It does exist. Let's look at 123. Okay, 123 exists as well. So yeah, just take that. But let's look at the symbol and see if there's a question mark. And the answer is no. So this one is not correct. So this one is invalid. So just put the question mark symbol is not valid. Okay, so this is the answer for this. Let's look at B. Complete the Backus null form BNF for the syntax diagram shown. Okay, so let's just look at the symbols. So we have 5 symbols here: $, percentage, ampersand, and then the @ symbol and also the hashtag symbol. So let's just put that in here. So this, and then percentage, and then N, and then @ and then hashtag. And letter there's ADPRY, such. Right? Then C, an identifier begins with 1 or more letters followed by 0 digits or 1 digit or more digits, and valid letters and digits are shown in the syntax diagrams on page 6, and draw a syntax diagram for an identifier. Okay, so I have no clue what identifier this is. We just put identifier. Okay, there's 1 line and 1 arrow. Okay, it begins with 1 or more letters. So it could be 1 or it could be long letters. So we can just put letter. 1 box. Okay, another arrow. Followed by 0 digits or 1 digit. So there could be 1 digit or there could be 0 digits or even more. So like that. Okay, so letter we can repeat. So it can be something like this. Digit, it could be repeated as well. Or you can choose to bypass it like so. Okay, there you go. That's the answer. 7a, complete the Karnaugh map for the following Boolean expression. Okay, so Z, not A, not B, not C, and not D. This one is 0, 0, 0, 0. And then ABC is not A, not B, not C, so 0, 0, 0, and D is 1. This one is not A, then B, not C, not D, so 0, 1, 0, 0. Then the last 3, this one will be 0, 1, 0, 1. This one is 1, 1, 0, 0, and then 1, 1, 0, 1. Okay, so let's look at which one does these correspond to. So AB00, CD00, we have that, so just put 1 in. And then AB00, CD01, we have that, so just put 1 in. And then 0100, we have that, so just put it here. And then 0101, we also have that. And then ABCD, we have 1100, we put that here. And then ABCD, we get 1101. and then the others we can all just put 0 because we don't have that in the Boolean expression. And then B, we need to draw loops around appropriate groups in the K-map to produce an optimal sum of products. So the optimal sum of products here would be these 4, okay, and also these 4. Alright, so yeah. Yep, and then write the Boolean logic expression from your answer to part B as a simplified sum of products. So since we already circled this, we can roughly know what we can come up with as a good answer here. So Z equals what? So so this one, it will be because we already know that there is not C, there's not C here. Not C is already for both of these, not C. And then there could be not A because of not A, you can see not A. And then there's also B, but there's also B here. B, that will be 1 and 1. So this one, if you were to shorten it down, using a Kahneman expression, this one you get not A, not C, okay. So it's not A, not C, plus because here you can see that not A, not C exists in both this circle. The plus here would be for the right hand side, and then B here is valid for 1, 1, and then not C still exists, so it could be B and not C. So that's why this is the answer. And then D, use Boolean algebra to give your answer to part C in the simplest form. So just take out the not C, and then not A leave in and B leave in. That's it. 8, outline the characteristics of massive parallel computers, basically a bunch of processors. So a large number of computer processors that simultaneously perform a set of coordinated computations it is also used as network infrastructure. By sending messages. Right. So 3 marks would be in large number of computer processors, and then simultaneously perform a set of coordinated computations, and then network infrastructure 1 mark, and then sending messages 1 mark. So total 4. So you have extra marks here. And 9a, it says encryption is used to alter data into a form that makes it meaningless if intercepted. Describe the purpose of asymmetric key cryptography. So all you know that you should know that asymmetric key cryptography contains both a public key and a private key. So here you can just put it provides better security by having a public and private key. The private key is used to used to encrypt the message, while the public key is used to decrypt the message. Okay, and B, identify two benefits and two drawbacks of quantum cryptography. Okay, quantum cryptography basically uses polarization of light or quantum physics in order to encrypt the message. It also uses fiber optic cables. So benefit one would be it prevents eavesdropping, basically intercepting by other people. As it can be detected. And then provide security based on laws of physics, which is more secure. But then there are a few drawbacks. First of all, very costly, as it uses fiber optic cables. And then polarization of light can change during transmission. You could even say that the fiber optic cables can only carry up to 250 kilometers, so very short distances. And then you could also say that it lacks many features such as digital signature. You can also write that as well if you want to. Right. Question 10. The pseudocode algorithm shown copies an active accounts text file, active file.txt, to an archive accounts text file, archive file.txt, one line at a time. Any blank lines found in the active accounts text file are replaced with the words account not present in the archive accounts text file. Complete this file handling pseudocode. So we need to declare account string, and then we need to open two files. So open file. This one would be your active file .txt. This one will be for reading. Because copies the text file to archive file.txt, so this is for read. And then, while not EOF, active file .txt, and then inverted commas and bracket. If account equals nothing, then write file archive file.txt. You see there's no mistake here, archive file.txt. Then we then put in these words, so account not present. Else write file archive file.txt, we can just put in the account, the data that is sent over, and then end while, then we can close both files. So close file, active file .txt. Okay, and that's the answer. Question 11. Pseudocode is to be written to implement a Q abstract data type with items of the string data type. This will be implemented using the information in the table. A constant with the identifier max size limits the size of the queue to 60 items, and write the pseudocode to declare max size, front pointer, rear pointer, length, and queue. So constant, so we need to declare the constant. Constant max size equals to 60, and then now we can declare queue. So declare queue array 1 to 60 of string, and then declare front pointer. You need to remember that this is not a programming language. This one is basically the pseudocode, so you cannot declare like two identifiers at the same time. So like so. And then length So declare length as integer. Okay. So now B, complete the following pseudocode for the function dq to remove the front item from the queue. Okay, so we need to remove the queue. So here we just see current size of the queue. So length has to be more than 0. So if length is more than 0, then item would be sent to the point to the start of the queue, which is queue front pointer. And then front pointer would be front pointer plus 1. Okay. Front pointer here doesn't display anything, so we go to 1. If length equals 0, then call initialize. Else, if front pointer is more than max size, then front pointer will then be set to 1. Okay, then that. Then otherwise you'll just say the print queue was empty, error, and then item nothing, and you can now return the item. Alright, so you can see what it's doing here is trying to remove the front item from the queue by actually moving the item from the array into the identifier item, and then you output the item in return item. Okay. C, it says explain how a new element can be added to the queue if it's implemented using 2 stacks. So basically, what you can do here, you can say that stack 2 can be used to reverse the order of the first stack. And then here you can say stack 1 operates as the queue with the newest elements. At the bottom, to add an element, pop all the elements from stack 1 and push onto stack 2. Because if you remember, in stack it's something like first in, last out. So when you push it into stack 2, this one you pop and it goes in here, and this one pop, it goes in here, and this one pop, it goes in here. And then then afterwards you add in another element, then you pop it back into the same order again. Alright, so yeah, and then you push onto stack 2, and then you push you can actually push the new element onto either stack, it doesn't matter, because after you pop it, it will go back to the bottommost position on the stack. So push the new element onto either stack and pop all the elements back into stack 1. Okay, so just to recap, let's say there are 4 items here, there's nothing here. Now you want to push everything, you just pop, 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 and then it goes, let's say this one is 1, 2, 3, 4. It become 1, 2, 3, 4. Okay, then now let's say you put in 5. Then you go back, then it will become something like 1, 2, 3, 4, 5, like so. Alright, so hope that makes sense. And 12a, describe what is meant by recursion. It's basically a process where the function calls itself, the process must have a base case. In this case, it will be a way to return without making a recursive call, depending on the condition. Or in this case, it can also be called a terminating solution. A base case and also a general case, so that the recursive call can take place by recursion. So this will give you 3 marks. Okay. Then B, a Fibonacci sequence is a series of numbers formed by adding together the two preceding numbers, for example 0, 1, 2. The function calculates and returns values and uses recursion. Then complete the trace table. So you start off with call number. So the call number here would be this one. In this case, the call number would be let's see. This one will be 1. And then function call would be fib5. And then the result would be, if number is less than 1, else result fib number 4. And then fib number 2. So you get fib4 plus fib3, sorry. So fib4 plus fib3. And then there's no return value yet. So now call number would be 2. And then fib4, number 4. And then this one you get fib3 and fib2. Okay. And then call number 3, fib3, you get fib2 and fib1. And then 4, you get fib2, you get 2, and then fib1, and then fib0. Okay, so then now we're starting to get the hang of it, because you see here that now the number will be less than or equal to 1. So if number is less than or equal to 1, then result is number, so that will be 1, and the return value will be 1. Okay, so then next thing is call number 6, and then you get fib0. Okay, fib0, we get number 0, result will be 0 and 0. Alright, and then we need to remember that we need to remember our result from previously, the fib4, fib3. So now we can just so now what we can do here is we can go into fib here is return value is 0, right? So now it's basically so it's basically fib2, fib2 because of call number 4, right? So call number 4, fib2, and then number 2. So now fib1 and fib0. So because of this, if you do recursion, because it's already 1, so you get result 1 and then 0. So this 1 plus 0, so you just get 1. And then move on to 3, 2, and 1. So 3. So 3 here would be fib3. Okay, 3. And then for fib3, you'll get you'll basically just get fib2, which is 1, and then you get fib3, 1, which is also 1, so 1 plus 1 equals to 2. And then 2, you get fib 4, and then 4, and then this one is fib 3 plus fib 2. So fib 3 we already know it's 2, so just put 2, and then 2 is, and then fib 2 is basically 1, so we get 3. And finally fib 5, number 5. So number 5 here we already know it's fib 5. This one is basically because just now we already know it's fib 4 plus fib 3, so we know fib 4 is 3, so let's put 3, and then fib 3 is 2, so 3 plus 2 equals to 5. And then that's the end of this recursion, and this is the end of this paper. Alright, I hope to see you guys again in the next video. Do share this video out to other people who may need help with A2 computer science. Till then, this is qiphyedu. Goodbye.